In this example, we will anti-differentiate the function sine 2x multiplied by natural log sine x. Kind of the intuition looking at the integrand, there's no obvious, say, algebraic manipulation that we could make, but there is maybe an obvious substitution, at least one that we can attempt. We see that the sine function is inside the natural log, so that makes sine a natural choice to try for the substitution. So let's go ahead and say w, the variable for our substitution, is sine. Then dw would be cosine x dx. So somehow in our integrand we need to manipulate the sine of 2x so that we can get the cosine x to come out of it. And here the obvious thing to do is to recall the double angle formula for sine. We can rewrite sine of 2x as 2 sine x cosine x times the natural log of sine x, which is there. And now we're good to go. This entire integrand can be expressed solely in terms of u. So sine x is going to be u, and the cosine x dx term, is going to be dw. And those sine x's would be w's. So rewriting in terms of the variable w, we have that this will be 2 times the integral of w natural log of w dw. So we have applied the substitution, and now the resulting integral needs to be evaluated. And looking at the form of this resulting integral, w times the natural log of w. This looks like something that's really well suited for us to attempt integration by parts with. And if we're going to attempt integration by parts, keep in mind that when we make our choices for u and dv, whatever we choose for dv needs to be something we can easily anti-differentiate. And if I compare w and natural log w, w is the function there that I can easily anti-differentiate. So we'll let dv be w dw, so that v will be 1/2 w squared. U is going to then have to be the natural log of w, so that du is 1/w dw. And integration by parts, tells us that we multiply together u and v, and then we subtract away the antiderivative of v du. So putting this all together, we're going to have 2 multiplied by uv, so 1/2 w squared natural log w minus the antiderivative of v du. So I'm going to go ahead and pull the 1/2 out of the integral, and then our integrand is going to be w squared over w, which is simply w. At this point, I'll go ahead and distribute the 2 through, which will cancel off the 1/2 in each term. So we have the first part, w squared natural log w, and we're subtracting away the antiderivative of w, which is 1/2 w squared. And then we'll remember our plus c. So just as an overview here, we started off by making a substitution, w equals sine x. Once we made that substitution, we needed an integration by parts to evaluate the resulting integral. Now that it has been evaluated, we just need to resubstitute to get back in terms of that original variable. So replace each of these w's with sine of x. So we'll have sine squared x, natural log of sine x, minus 1/2 sine squared x plus c.